Okay, so piecewise functions are not scary. They are simply functions that we graph in pieces. So it's real simple. You just do it a piece at a time. So here's a couple of examples. First example. All right. Take a look at the top equation. It literally says y equals x plus 1. So I'm going to graph the equation y equals x plus 1. Now you can do this in two different ways. You can either graph, just from the beginning, graph only the part of the line you want, which is the part where x is greater than 1. So, if I set up a t-chart, I'm going to go ahead and let x be 1, and that would give me 2. But I'm going to plot that as an open circle, because that's a greater than, not an or equal to. So it's the same theme as we had before. So I'm looking at just the top equation. It says, when I set up my t-chart, I have to have x's that are bigger than 1. So I'm going to start with 1, and then I'll do 2 and 3 and 4, and as many as I want to do. So I plug them in. 2 would give me 3, and then I'll plot those. So 2 comma 3, 3 comma 4, and there is the part of the line that I want to sketch. Now I want to give you another option, because this works for some kids better. Does everybody recognize this is a line with a y-intercept of 1 and a slope of 1? So up 1 over 1, up 1 over 1. So this would be the whole line. Does everybody recognize that? This tells me, though, that I only want the part of the line where x is bigger than 1. So that would be right here. That's where x is equal to 1. And none of this is allowed. Now, I end up with exactly the same picture, don't I, as I had before, but I did it differently. So some kids like to just sketch the part you want. Other kids sketch the whole thing and then erase the part that you don't want. So how did I know to erase this part? Because the directions tell me I have to have x's that are bigger than 1. So then I go to the next step, and I repeat the process. And again, either sketch the whole thing or just the part that you want. So this one says, get this picture out of here. This one says y equals x squared. The equation I'm graphing now is the middle piece, y equals x squared. And the x's I'm supposed to be using are x's that are less than 1. So I'll start with 1 again, and then I'll pick numbers less than 1. X is less than 1. So if I put 1 in, I get 1, and that's going to be an open circle. If I put in 0, I get 0. Negative 1 gives me 1, and negative 2 gives me 4. Now, what shape is that? It's an x squared, so it's going to be a parabola. But it's only a piece of the parabola because we had to start where x equals 1. What does the bottom line say, the bottom piece of the equation? Y equals negative 3 if x equals 1. What's that? That's a what? That's a point. That just says if x is 1, y is negative 3. That would just be this point right here, the point 1 comma negative 3. If x is 1, y is negative 3. And that's a picture of your piecewise function. Is that a function? Yeah, it passes the vertical line test. Remember, those two dots are open. So when I pass a vertical line down through, it only hits that one place. Okay, what's the domain? Let's talk about that. What's the domain of this thing? Very good. This is your domain right here. It says x is bigger than 1, less than 1, or equal to 1. Doesn't that about cover everything?
Yeah.
Yeah, that's your domain. Now your range is a little tricky on this one. Anybody want to take a stab at what you think the range is, Lane?
Greater than 0.
Greater than or equal to 0.
Zero.
Mm-hmm. Exactly. That is your range exactly. Your range is all the y's bigger than 0 or equal to. We've covered that. And then this little dot down here, we have to take care of him, so -3. Very, very good. Continuous or not continuous? Definitely not continuous, right? We had to draw it in pieces. Bounded? Below where? Where's it bounded below? -3. Bounded above? No, the line and the parabola both shoot up. What's some of our other vocabulary? Do we have any x-intercepts in this picture? Yeah, 0, 0, which is also the y-intercept. Serves double duty. Increasing or decreasing? Watch it, left to right. What's happening here? It's decreasing. What's happening after that? Increasing, except for this guy down here. So from here to here we're decreasing. Here we're increasing. On that interval we're increasing. And then from here on we're increasing. Okay, that's it. Let's try the next one. All right. Andrew, did you have a question or you just okay? All right, let's go. Did Emma, did you have a question back there?
Figured out the domain. It's just all real.
Yes.
Okay.
Right here. That's everything. Okay, let's guess this one. All right. What's that going to look like? That's going to be a V, isn't it? And isn't it just going to be the standard old regular V? Except for what? Except for where x is 2, which is right here. How do I indicate that? What am I going to do to indicate that?
Open circle.
Open circle right there. Very good. It's the whole absolute value curve except for that little hole in it because they said x can't be 2. All right, and then what's this? Watch it. It says y equals -2 if x equals 2. So what ordered pair is that? 2, -2. That was easy. What's the domain? It's all reals. Because didn't we cover all the bases here eventually? All real numbers are your domain. What about your range here? Everything greater than or equal to 0 and -2. It's just like this one. Okay, you got that? All right, so tonight we're getting a chance to do some of those. Let's spend some more time with the questions that you may have had in homework last night over your 12 basic functions and their properties. I can't remember on Friday how much of this we talked about, but I want to make sure we're all clear on the impact that 3 has and the impact that 3 has. I want to make sure we get that. Also want to make sure we get the impact that has. Okay, so let's talk about this for a second. first of all, what general shape here? It's going to be a V. So the regular shape that we're starting with is just this right here. And we know that because the absolute value function is one of our 12 basic functions, and you have been charged with memorizing those shapes. So absolute value is going to be a V. Now, what impact does this 3 have? That's going to move it up 3. So this one is going to look like that. So you gotta know this. When you stick a number onto the end, plus 3, minus 5, plus 16/3, whatever it is, that's going to move you up and down. It's called your vertical shift. That's going to take us up 3 units. As opposed to putting the 3 inside the absolute value with the x. That is a horizontal shift. What would this one do? 3 units to the right. That one's going to go 3 units to the right. So if you had a problem like this, where would that V be located? You've done 2 things now. What does this do? To the left 2 and up 1. So that V would look like that. Now what does this negative do? We talked about this a little bit, or there were some problems like that. It flips it upside down, so that V is going to look like that. Okay, these are critical things. And do these rules apply only to the absolute value?
No.
No, they apply to all those pictures that you learned. So for example, which function is this one? You gotta know this. That's the square root function. So this would be y equals root x. So if I did y equals the square root of x minus 2, what would that do? Right 2. It does exactly the same thing the v did, only it's a different shape, but it's still going right 2. Okay, all your curves function that way. Sticking a number onto the end is a vertical shift. Attaching a number with an addition or subtraction to the x is a horizontal shift. All right? Okay, so now you've got your homework out, hopefully. What questions did you have about your homework on page 113? Madeline?
Well, I don't know if it's on here, but like, how can you tell if it's either or odd?
Huh?
How can you tell if it's either or odd?
Oh my goodness. How can you tell if it's even or odd? What's the rule? It's all about symmetry, right? And which symmetry? Odd is the origin. So if someone said to me, is this function odd, and I'll just use an absolute value function. If somebody said, is that odd? I would do my test of symmetry for the origin. And what is the test of symmetry for the origin? Switch both signs. That's exactly right. Somebody said it. Switch both signs. That's your test of symmetry for the origin. Now, what is the absolute value of negative x? It's the same as the absolute value of x, right? Is this equation the same as the original one I started with? No. So it is not odd. There is no symmetry about the origin, so it's not odd. All right, what's the test of symmetry for to be even? To be even, I'm testing for y-axis. And what is that test? Change the sign on x. Okay? Now, absolute value of negative x is the same as the absolute value of x. So what happened? When I changed the sign on x, I ended up with the same equation, didn't I? So what does that mean? It does have symmetry about the y-axis, which means it is even. So this one is even. because it has symmetry about the y-axis. All right, who had a question about a homework problem? An actual question about a homework problem that you had to do it? Reason?
Well, number 25 and 26, I just kind of confused by like hold on that.
All right, let's just start with 25. The 4 functions that do not, now these are the 12 basic functions now. These are not the pictures they drew. These are the 12 basic functions that do not have end behavior like that. And what that end behavior means is, as x gets bigger, y gets bigger. So this would have that end behavior. As x gets bigger, y gets bigger. It shoots up off into space. That's what this means. As you get bigger with x, y gets bigger. Okay, so that one would not. So we're trying to find the ones that do. That one does have that. We're trying to find the ones that don't.